There we go. Hello everyone and welcome to Handmade here, the show where we code a complete game live on Twitch. We don't use any engines or any libraries here. There are no engines or libraries here. I fully expect you all to have left your engines and libraries at home, because if I see anyone out there on Handmade Hero using an engine or a library, there will be significant consequences, people, okay? This is not fun and games, all right? It's not some big circus where you can just program anything you want and everyone's going to be okay with that, all right? This is serious. You know, this is a serious, topical game about an orphanage for limbless children, and if you cannot get on board with that, all right, then I just don't know what to say. Maybe you need a timeout. But while you're taking that time out, what I would like you to do is think about the fact that today is day 141. And so if you would like to follow along with me without engines and libraries, you will want to unpack day 140 source code into a directory, because that is the source code we will be starting with today. That is it. Now that we've gotten that out of the way, and I hope everyone is behaving themselves out there, we need to decide what we're going to do today. So let's open things up here. If you remember, we left things off. We had made some audio mixing funnesses here, which I think we left it where I actually launched an entire new musical score every time you threw one of the little rocks out, one of those little test rocks. And so eventually it just got absolutely cacophonous and weird. But I think we were just doing that because someone asked whether you could play the same sound multiple times. And of course the answer was yes, and that was the best way to demo it. So we've got that straightened out now. So hopefully we can, maybe not do that anymore and switch this back to something that isn't going to be too cacophonous, like asset bloop. And here we go. All right. So there we go. All good. So what we want to do now, I think, if I'm not very much in error, is we've got like two things we might want to take a look at in terms of how we are dealing with sound mixing. One of them is whether or not we want to support streaming sounds, and if we want to support streaming sounds, how do we do that? And again, when I say streaming sounds, I don't mean like asset streaming, which we've already implemented. I mean more like a single sound, instead of being streamed in as a chunk. It can be streamed as like one chunk. It can be streamed in as like many chunks. So, if you have a piece of music that's 30 megabytes long or something like this, you don't have to pull the whole thing in at once. You can pull in little pieces of it, which maybe takes off a little memory pressure, maybe takes off a little load pressure. Do we want to support something like that? And maybe we do. So there's that we can take a look at. The other thing that we want to take a look at is adding a little bit more functionality to the mixer, stuff like volume ramping over time, so you can kind of fade things in and fade things out instead of only being able to just set one volume for things and leave it there. And that would also give us like panning back and forth if we wanted to like move things around over time. So we have some stuff like that we probably would like to have happen. And we also probably want to drop our mixer down into SSE just to make sure, SIMDize it, just to make sure that everything is kosher there. So we have a lot of things that we could look at in that respect. And I don't know which one is necessarily the most logical. I think probably what we would want to do first is take a look at the streaming stuff, because that would affect the way this loop kind of works at a higher level than the other things would. Like the other things are kind of about interpolating values inside this loop, which is not really all that relevant to anything. Meaning, we can add interpolation in these loops and there really isn't going to be a whole lot of consequence to the external code. But if we do want to have our sound loaded in pieces, that has a bunch of ramifications that we might need to think about in terms of how our asset handling works. And so we might want to, look at that a little bit more carefully. So maybe let's try that. So here's what I am thinking. Here is what I am thinking. We have our assets stuff set up here, right? And when we have a loaded sound, that loaded sound, we bring that in as part of our asset streaming system. Obviously, it comes from an asset slot that's backed by one of these info things, right? Asset sound info. And so asset sound info eventually will probably contain a little bit of information. Right now it just contains a file name because we don't have an asset file format yet, so we're just actually loading WAV files just straight off raw directories on Windows, right? But in the future that'll probably have stuff like what the offset is in the pack file that we're going to read out of, and if it's compressed or any of the other things that we might need to know, that's going to go in there. And so it seems relatively cheap for us to take a look at this asset sound info thing here, and we could add to that something that just says, hey, there are some number of chunks to this sound, right? We could say that there are a certain number of chunks to the sound, and then we could load those chunks independently. Now, the problem with that's kind of the obvious thing to do, right? That's kind of the obvious thing to add here. The problem with that is that our entire asset streaming system works off of the concept that a slot is the fundamental thing that controls whether something is loaded or not. And so what we really don't want to do is extend that concept any further than we have to, because if we have our whole system working so that we can stream assets based on whether, on what their slot status is, so we can basically say, oh, is this thing that I need loaded or not? I can look at the slot and find out, right? If that's the way we're doing things, then it seems like what we would want to do is figure out a better way to put that asset info into to pull that asset info out a step further, so that every chunk of a streamable sound has its own asset slot, and then that way when we go to stream it, it doesn't have to think in any other way any different than any other of the sound streaming components would work, right? And so let's take a quick look and see if maybe there's an easier way for us to do that, right? So if you see here, we've got our asset tagging system, right? And our asset tagging system would actually allow us to do this if we wanted to, right? Our asset tagging system would allow us to do something like just sort of having a tag that advanced through time, right? We could have a tag, the ID value was like, tag sound section or something like this. And we could have values that just went like 0, 1, 2, 3, 4, 5, 6, 7, whatever. And then, break it up that way and look into the tags. Now, that actually would just totally work, I think. All we would have to do is in the asset sound info, we could just put a little thing that said what the maximum tag value was for this particular sound, and then it would just work through the tag system just fine, right? But I don't actually know that we want to, there's a consequence to doing that. And the consequence is that will now get matched along with everything else. And I guess we could use weighting to avoid it, but what that means is that if you look here, we've got asset music, and presumably the way that we'll use asset music is we'll have a bunch of tags that describe the kind of music, and then we'll ask for a match, and we'll get back, a match for a particular type of music that is then the music that we want to play, right? And so then we've got a sound ID, and the sound system's going to get that sound ID. It's not really going to have a way of getting back to what the tags are that it needs to feed through in order to rematch that entire sound ID, right? So it has consequences. I'm not sure that would actually be all that easy to do. We could obviously make some changes, but I don't know that that's the best way to do it, right? So if we actually have just a sound ID and we want to somehow get to like the next sound ID, what we could do instead, and this again seems maybe like an easier way to go of it, is if we already are going to have a loaded sound that comes back from this, maybe what we could do is just introduce the concept of chaining these sounds together. So for example, is there any reason that I couldn't just say, there's a sound ID here, right? And it's going to be the next ID to play, right? Something like this. And so when I load a sound in, I'm going to have it right in the data, where if I get to the end of this sound, I'm going to want to play this other sound back to back, like lined up perfectly with it, and then allow the streaming to proceed that way naturally. Because that way we just pull out one of these sound IDs from the tag match, and we really don't have to do anything else beyond that. So just thinking it through out loud to myself here, I feel like of the options that we have, that one seems to be the most promising. And if that sound ID were to be set to 0, that would mean that you don't have to do that anymore. Furthermore, if you set that sound ID, I guess you could imagine setting that sound ID to yourself. That would be a sound that looped forever. It would just keep playing and playing and playing. I don't know if we want to take advantage of that, but we could, right? So if we were going to do that, what I guess I would say is, you know, in this asset sound info, we just go ahead and put that in here, next ID to play. And that way, when we go to load, you know, that sound info, we would just get it. And in fact, I guess since those are lined up with slots, to be honest, I guess we really don't even need that, because assuming that we know what the sound ID actually is, we can always go ahead and get the next one from it too. So just looking at this, let's take a look at what we would do if we wanted to just leave it in there. So here's me getting the loaded sound out, and we're playing the loaded sound here. Now, assuming that I got the loaded sound, it's a good bet that I'm going to want to make sure that its next sound would also be in there. So I want to do something where I say, oh, you know what? Why don't you go ahead and load whatever the next sound is as well. So the asset slot, right? Where is that asset slot? Asset slot, right. I want to be able to get this out, right? So I want to be able to do a thing, asset sound info. I want to be able to do a thing where I can get back the sound info that went with this loaded sound, right? So I'm going to go ahead and say info, and what I should be able to do here is say something like get sound info, and know that as long as I had a valid, if I was able to get a valid loaded sound, I'm going to be able to get a valid info as well. So when I get that info out, I'm going to want to say next ID to play. That should actually give me something, right? Info next ID to play. Oops. There we go. And I'm just going to say queue it up, because whatever it is, you know you're going to want to play it. Now I assume, I guess I don't actually know, I assume we guard for 0 in here. Yes, we always do, so that's good. So it's always free for us to just say, hey, load a sound. Even if there is no sound to load, it'll just ignore our request. So when we do this, we now know that we will have another playing sound that will come back. So what happens now is if we get to something where we have samples to mix here, and we get to the end of samples to mix, which you can see us doing here, what I want to do is, instead of just exiting out of here, I want to, and removing, you know, the sound, right? I want to go ahead and play the next sound. And what I'll do a simpler version of it first that will actually cause a skip in between them. Basically what will happen here is, if you imagine getting to the end of the sound, the mix buffer may be a certain width and the sound buffer is less than that, we would leave zeros. We wouldn't fill anything in that end of the sound buffer, but then the next frame we'd do more. So I need to do something a little more complicated to make the playback seamless. So for the minute, and I guess I'll do here, make playback seamless. For the moment, what I'm going to do is I'm going to actually just convert this directly to an if, and we'll do something a little more fancy in a second. So I'm going to say, all right, if the sound would have finished, right? Then what I want to do now, instead of just assuming that the sound is over, I want to see whether the next ID to play, right, is actually valid or not, right? So I don't know if we have in Handmade asset, I don't know if we have an is valid of some kind. Looks like we don't at the moment. So I'm just going to go ahead and put one in here that's like, you know, bool 32 is valid, and you can give it a bitmap ID, like so, and you can also give it a sound ID, and sound ID, there we go. And what I want to do here is I want to check the value, and I want to say if the value is not equal to 0, then it is valid, right? And that is the entirety of it. So I'm going to check to see whether this particular sound is actually valid, the next one that's supposed to be playing. If it's not, then the sound actually is finished. But if it is, then what I would like to do is, you know, you can take a look, and we've got this playing sound guy here, right? you can see that the only real thing that he has about that he knows about is just the ID and the samples played, right? So all we really have to do to change him to playing another sound is we just go ahead and set the ID to be whatever that thing was, right, that we wanted him to play next, and then reset the samples played to be equal to 0. That's it, right? There's nothing really to do about it that, you know, there's really nothing fancy about that. This is a prefetch here. I guess, you know, the other thing I should say, this is a prefetch. So the other thing we might want to do is actually just make it known that this is a prefetch, meaning we don't actually need the sound right here. We're just prefetching. We're just requesting a prefetch of the sound. So maybe what I actually should do is name it that. Sorry, I just thought of that because we haven't actually talked about prefetching. That's just to say, hey, asset system, you know, this is going to be coming up. You probably want to get on that, right? You know, don't be the kind of person who just leaves it to the last minute. That would be bad, right? And so we've got, let's see, we've got load sound, load bitmap. So I want another thing here, which is like prefetch sound and prefetch bitmap, like so. And really, for now, these are just going to be literally, you know, passing right through. They're not going to do anything at all. But in the future, we may want to know the difference between something that's saying, hey, I need something right away, and something that's like, you know, well, I'm letting you know that I'm probably going to need it, right? Because those are two different actual requests in some sense. Okay, so let's see here. Well, we've got a sound ID. That these guys need to be moved up if we're going to be talking about them, so there we go. And we need this actual call to get sound info, which we can put in here. We've got our call to get sound, which is here. And so our call to get sound info is going to be very similar. So get sound info. Here is our game assets and our sound ID, like so. And I am just going to go ahead and grab it out of the assets. And so there's our result. Return result. And we could start asserting these as well. This is a place we could put in a little assertion just to, you know, check to make sure that nothing bad is happening, right? So we could say make sure the ID value is less than or equal to the asset's sound count or something, right? Because we know that they need to be within that range. Okay. So here we go. Let's double check these just in various. Let's see, bitmap count, like so. The other thing we might want to do here is say that if it was 0, we might want to be a little bit more forthcoming about that. Like, you know, we might want to say like value, if the ID value is something, we actually grab it. Otherwise, we don't. Of course, that'll actually, I guess, work here. So the only place we actually need to do it, I guess, would be in here. But maybe we just want to return the null sound info. I don't know. That's a tough call. I'm not sure. All right, so let's see where we're at here. When we actually, the only thing that I think we'd have to do here is when we actually add these sound infos, right? We're going to have to do a thing where we say, okay, whatever that next sound to play was, next ID to play, we're going to have to assume that that is 0 for now, right? What did I do wrong there? Sorry, it's value. But other than that, I think we're okay. So let's go ahead and see how we're doing here. All right. So that's all good. So now what we got to do is we have to extend our notion of sound info a little bit, right? So, you know, our asset sound info thing here, we'll have to have some opinion of what section of this file we're actually looking at, right? So we're talking about saying, oh, we want to read a particular sample count and we want a particular sample index, right? So now our asset sound info would actually say, you know, here's the range that we're actually talking about for loading these sounds, right? If that makes sense. Now what we can do here when we actually go to to do our load sound. Let's take a look at how the info works out here. Debug add sound info. Where's the actual load sound work? There we go. When we load the info out of here, right, and we ask for that file name, what we would want to do is we'd want to pass, the sample count and that first sample index, right? We'd want to pass those from the info. And so when we initialize them, what we could do, just to make it a little easier on ourselves, now these could all be set correctly in the future, because they would, in fact, you wouldn't even need any of this stuff really. I guess sample count would probably be in there once we actually have a file format, because it's going to say like basically how big the sound is in the pack file or something like this. So you'll have something like this eventually. But what we're doing right now, I'm just going to make it so that if the sample count is set to 0, then I'm going to assume that it just means read the whole WAV file, right? Because you would never actually make a sound chunk that had 0 in there. So what I'm going to do now is say, all right, we've got that debug load WAV file. In here, we're now going to be passing it a first sample index, and we're going to pass it a sample count, right? And then when we go ahead and read these things, and I guess we'll also say window sample count and window, because we're kind of looking at a window into the sound, so maybe we'll call it that, or section, something like this. So when we come in here, we've read everything, we do all this result stuff, right? And again, we don't care about this code at all. We really just don't care, because this is not going to be code we actually use at all. It's strictly stand-in until we have that pack file set up where we can just know exactly what we're reading. So when we do this debug load, at the very end, all we really have to do when we do the result is just sort of monkey with the result a little bit when we have this loaded sound. We can basically say that, if the section first sample index, oops, didn't mean to make that still be called window, there we go. Well, if the section first sample index is not equal to 0, then we want to sort of do an advance. I'll do a little assert here that the section first sample index, plus whatever the section sample count is less than or equal to the actual sample count of the actual file, right? Because that would be bad if we, didn't do that. But anyway, assuming that it's set properly, we're going to set the sample count equal to the section sample count, so we'll just get rid of what the old sample count was going to be, just truncate it. And then the samples, each of those, both 0, I guess we'll just do for, channel index, right? U32 channel index, there we go, equals 0, channel index is less than result channel count, plus channel index. And for each of the channels, we will just go ahead and add whatever that first sample index is. So, moving them up to where we would want them to be if we were just playing out a chunk of the file, right? So hopefully that makes sense. I keep forgetting I've been experimenting lately with doing this. I don't know how I feel about it. I don't know how you guys feel about it. I've been kind of liking it lately, to be honest. The terseness, I think, in my old age. So, I basically have been saying, what if we just had things that look like this? I think this is the way I was doing them. Right? This is kind of like, Jeff Roberts, I think, often does this. He has, defines for things that are, as terse as possible. And I don't know, they're so fundamental that I kind of liked it. Was playing around with it at work, and I was kind of liking it. So I don't know. I don't know how people feel about it, but I kind of feel like it was kind of cool. I don't know, that was my opinion. Oops. I always manage to get those backwards. I always think of type defs like they were defines, And so I get the parameters all the time confused because I think of them as being, I'm saying what I want to define, and then I'm saying what it should be, just like a define would be, which is the opposite of what you actually want. But anyway, so let's take a look here. So we've got result sample count there. Looks like we need this to, that looks like our only actual one is result sample count. So now if I run this, I'm hoping that we essentially won't, yeah, we won't have any change, and that's good. And so now what I'm going to do is I'm going to take that music asset, right? And I'm going to start experimenting with the music asset to put us into a position where we can test to see whether streaming in this way, streaming the music in this way, works, right? So when I do add sound asset, what I'm going to do here is I'm going to say, let's just take only 1 second of music, right? And just extract a chunk from it, right? And then add sound asset is going to obviously have these guys, so it'll have like a first sample index, and sample count, right? And those will default to 0 so that people who are just adding one don't really have to care about that at all. Wait a minute though, where's my info? Add debug sound info, so it needs to pass it in here, right? So I need to pass it like this. First sample index, sample count. There we go. And then this guy up here will have it like so. There we go. So that looks reasonable to me. First sample first sample index, always good. Sample count. And so let's see if we can get it to just play 1 second and then stop, right? Which is what should happen. All right. I'm just going to go out on a limb here and say that that did not work. You know how I know that? Because the sound was still playing after a second. That's regrettable. It's unfortunate. It's not what we wanted to have happen. It's true. So, you know, probably the right thing to do at this point is just to give up and to stop programming, you know, forever. Because really it's about just saying that once you've been defeated, you should never, ever try again. Or another thing we could do is externalize blame. We could say that that had something to do with the sound card or some kind of really lousy compiler bug that was messing us up. So there's a lot of things we can do here to avoid having to actually confront the fact that we did a lousy job. And when I say we, I mean me, but that of course is another way to externalize blame, is to widen the scope of who is responsible for the problem to people who really probably didn't have a whole lot to do with it at the end of the day. You know, that's obviously, you know, one technique that I highly recommend. Now let's go ahead and just say, for the sake of argument, that we were actually going to be diligent so-and-sos who are going to look into the actual problem and solve it. What would we do? Well, we know that we're playing a little bit too much, so the first thing I'm going to do is I want to see that load wavefile call, and I want to see that it's actually processing this section. Okay, so that was my first guess, that it wasn't ever actually processing the section. Turns out that's correct. So basically, we come back here and we see, why are we not passing something? Oh, well, this is great. We didn't actually use the value that I said we were going to use. I said it was sample count. First sample index obviously could be 0, no question, right? That's the first one, we'll always have that being 0. It's the sample count that I said would be the one that we switch on. So that's just a case of me not even doing what I said that I was going to do. So let's try that again and see here. There we go. Now we're in there and doing a little bit more of what we said we would. So let's take a look at what happens now. Much, much better. Right? We just get 1 and then it's over, right? So that's good. That's a good start, but we've got more work to do here, obviously. There is also, well, all right. Let's just keep going here. So what we want to do here is we want to go ahead and allow ourselves to do add sound asset in a way that makes sense in terms of this extraction. Now, what I think I want to do is I just want to say like 1 second equals 48,000 for now. We'll just, you know, we don't even know, or we'll say 1 chunk, you know, 1 music chunk equals, let's say, 10 seconds of music, something like that, right? and we'll say that we want to do one music chunk. What I want to do is I want to have add sound asset automatically sort of do the work of tracking as we add those chunks. This is just a convenience feature to me. Like I said, this code will be removed because the actual asset pack file will already have these things laid out for us. But we need to do something, first sample index. Oh, now that I think about it, I guess I could just do that though. Yeah, never mind. Never mind, I was about to say something stupid, or rather I already did say something stupid, and now I'm just gonna have to take it back, so that's fine. So what we could do here is just track them both ourselves, and that's fine. So the only thing I really need add sound asset to track for me is the next sound to play bit. And I guess even that I really wouldn't have to. In fact, I guess, yeah, we could just have it so that this thing returns the sound info, and that would really be it, right? Add sound asset could just return the asset, like this, right? Return asset, and oops, not return assert. That would be bad. So what we could do here is just say asset last music equals 0. Because again, like I said, this is just code for just doing our testing, so we don't really have to care if it's sustainable or interesting or anything. It's just whatever makes it simple to put things into sort of the fake format for our testing purposes. So when we're done here, we can basically say, all right, asset this music equals whatever. Then I can just say last music equals this music, and now we know what the last music is. So what I can do is say, all right, if there was a previous music, then whatever its slot ID was, I just need to go ahead and get out that sound info, right? I just need to do get sound info on that slot ID, right? Well, I guess I can just even do it like this, right? So I can say sound infos of the slot ID. So whatever the last music was, I want to set its next ID to play equal to whatever this slot index actually was, right? So this music slot ID, like that, right? That should do it. So really all we have to do here is know how long the actual file is, right? And so if we wanted to do a few different chunks, we could do something like this, but I'll actually go look up what the actual sample indices are. Let's see here, slot ID, there we go. And one other thing that we probably would have to do is actually double check in here when we do load wave. We'd want to make sure that the sample count itself, maybe instead of doing this as an assertion, we could do this as a truncation. Well, no, I guess we could do it as an assertion. The assertion would probably be fine, and then we'll just take care of it at the head end. Good. Perfect. We are now streaming in music. And you could hear, well, you probably couldn't because you're in secondary compression land, but there's a little click because, like I said, we're not doing that gapless playback yet. So the mixer isn't actually really doing what it needs to do quite yet, but the streaming's working fine. So that's good. So let's take a look at how many sound samples this WAV file actually is, so we can finish up our little loader thing there and make sure that it's reasonable. So I want to take a look at result sample count. Of course, I can't do that because the magical compiler never knows where any of the values are, and that's always good, because why would you know? It's not like you output the code or anything. So let's go ahead and copy and paste that in. And so inside Handmade asset, when we actually make that sort of fake thing here, what I can do is just say total music sample count equals that, whatever that number is. That's how many they said there were. And so then what we can do is say, well, we want to go until then, right? And sort of the sample count that we're going to want in here is going to be one music chunk unless that's actually going to be greater than however much was left. So I guess what we could say is do it actually this way, right? we'll say the sample count is however much is remaining, right, in the file, and assuming that that's less than one music chunk, we'll use it. If it's greater than one music chunk, we'll just use one music chunk, and then we move along like that, right? So that should get us right to the end of the file and then stop, right? So I think that's all we really want. That should be fine. Let's take a look here. Oh, right, and I forgot, of course, we don't make our frame in debug mode. I think what we should probably do to stop having to, switch between these two is just compile just the blit code in the texture mapper, basically. Just that one. We could compile that in a separate file that has optimizations turned on, so that we basically get, all the speed that we normally have, but without having to constantly switch back to debug builds. Because the rest of our code runs plenty fast. It's only just that graphics intensive part. Yeah. So I think we're all good there. So let's go ahead and ping back to the mixer and take a look at what we're doing with the mixer there. And it might be time to pull out the mixing stuff into a separate file, just because we can kind of button it away and just say, here's sound mixing, just like we did with the rendering. So if we sum all the sounds here, what you'll notice is we've got that skip because in our little to-do make playback seamless. What happens here is if we run out of samples, we just full-on stop the mixing process here. But what we actually want to do is first allow ourselves to switch to another sound if there was another sound that was supposed to happen after this one, right? And if there was, keep on mixing, right? That's what we actually would want to do. And so what we might think of here, right, is actually having this guy in like some kind of a loop, right? So I'm just sort of thinking out loud here, but suppose that we go ahead and do this. We're going into this loop. We want to do this loop until we actually fail to load a sound or the sound is actually finished, right? And so I guess one thing we could actually say here is we could actually make this a while on sound finished, set it to true, or I should say while the sound is not finished. We come in here and we will do this until we consume all of the samples in the, fill up an entire sample's worth of sounds, fill up an entire buffer's worth of samples, or, we get to the end of the sound, or we find that we can't load it, right? So we have a bunch of reasons why we might want to break out of the loop, right? All right. So first of all, we would break out of the loop if we had to load the sound, because that means there's nothing for us to play, right? So that's fine. Let's see here. We break out of the loop if there's nothing else to play. We break out of the loop if the sound is finished, which is also fine, and then we would remove it, right? And so we also want to break out if we ran out of actual samples, right? So if we consumed all the samples, we would break as well, right? It's kind of a nasty little loop. There's a lot of reasons why we would exit it. Maybe there's a better way to structure it. We'll have to think about that as we go. So we come in here, we're loading the sound, we do all the stuff we want to do. If we get to, the only thing that's a problem here is right, the samples to mix and samples remaining in sound. This stuff needs to actually be kind of, needs to now persist outside of the loop, right? I guess that might be a way that we could make this work a little bit cleaner as well. Yeah, but anyway. So we come in here, we know that we want to try and mix sound into the sound buffer to fill it completely, right? We know we have a certain number of samples to output. We want to fill that completely. So we're going to start with that. We know how many are remaining in this sound, right? And so what we want to do is say in here, we kind of have, like, this is almost like a total samples to mix, right? And so when we come in here, we've got a samples to mix equals total samples to mix, right? And then we will sort of truncate that. And then what we would do at the end, when we sort of update our, well, actually, where is that? Oh, here it is. Playing sound samples played, right? Excuse me. When we update this stuff, which I think honestly should probably happen up here, right? Like, isn't this a little busted? Is this right? Like, shouldn't this check be happening? This check should be happening after we advance, right? We mixed all these samples. We should then, right? I mean, that was in the wrong place. It would still work because the next time through it would do its thing, but that was not in the right place. So we want to actually do that check here. So when we actually update the samples played, we will also now take the samples, the total samples to mix. We will subtract however many we mixed, right? So this will decrement to 0. And so that's actually also a thing that we could do there, that we could also break on. You know, we could say while total samples to mix and the sound is not finished, right? Well, both of those things are the case. Because that would also then allow us to just sort of do this. And let's see. If it's not equal to, that's okay, the total set. So all we would have to do is just basically say, yeah, assert here that total samples to mix equals 0. Because we assert that if we didn't finish the sound, right, if we didn't finish playing the sound, we should have consumed all of the samples in the buffer. We should have, like, filled all of the samples in the buffer. So that's a little janky. It's hard to write complex loops on stream, I find, and talk through them. So I don't know how reliable that code is going to be, but let's see. Oh, and the other thing that I guess we could do here to make this a little bit easier to hear problems is we could reduce this down into like 2 seconds, you know? So I'm still hearing a little skipping there. So I don't think we're quite ready yet with what we're trying to do. So let's see here. Let's see. I might just want to set a breakpoint and check this case, but I want to read through this one more time because, like I said, it's hard to write these on stream. I want to make sure I actually wrote the loop I thought I did, and you know that's a little bit hard to do sometimes. So okay, we start off with however many samples are in the sound buffer that we're trying to output, and we say that's the total we want to mix. And so as long as the sound is still playing that we're trying to play, and the total number of samples that we have left is, you know, not 0, right? There's still something left. We're going to go ahead and try to get that sound. Now, if we don't get the sound, then we are going to go ahead and try to load it and break out because there's no way we can actually put anything in the buffer at that point, right? It's a non-starter. But assuming we can, what we're going to do is get the info, and we're going to try to prefetch whatever comes after this sound because we know we're going to need it relatively soon, right? We'll then grab those volumes out, and we'll get the destinations here. Well, that's obviously a problem there. These guys also need to be persist through the loop, right? Because as we move those forwards, we need them to continue. So yeah, I didn't write the loop I thought I did, as I surmised. That's how it goes sometimes on stream. So anyway, we grab the samples to mix, and we set that equal to however many there were left. We then clip that, basically say, well, if there were samples remaining in the sound, if there weren't enough in this sound itself, then we're going to need to stop early, right? We then go through however many samples we said we were going to mix. We mix them in. We advance the 2 destination pointers. We then come back and we say, all right, the number of samples we played in this particular sound, we advance by the number we mixed. The number of samples that we were trying to mix, we decrease that by samples to mix. And I guess we could also assert here, right, that total samples to mix is greater than or equal to samples to mix. Like that should never be the case that it goes any other way. So we do that. We then go ahead and I guess we can delete that because that's what we're doing right now. We then go ahead and see if we got to the end of this sound. We're going to see if there's another one to play. If there was, we set it, and then we come back through the loop, right? We're not going to break out of the loop. If there isn't one, then the sound's done and we're out of the loop. Like that's just a done deal. And if for some reason we did not consume all the samples in the sound, that must mean that we filled the buffer completely. So let's assert that we actually did that, and off we go. All right, so I think we fixed at least one obvious bug there. And that sounds nice and smooth to me. Lovely. All right, so I guess what I would say is that seems so easy for us to support with the way that we've architected things. I feel like we just should. I don't know that we're ever going to actually need it. It may be that, you know, we've just got so much memory on most of our platforms that the right thing to do is to load the whole sounds at once anyway, but that's just so easy to do. I would say, why not load music in 10-second chunks? Just in case we want to run on more memory-constrained platforms, that'll put us in a better position to do so right off the bat if we know that all of these systems are capable of working in very confined spaces and being able to swap things out as necessary. So that seems pretty good to me. I'm going to go ahead and say that's a useful thing to support. So that's good. We've got all that done. And so maybe now I've got about 10 minutes left here. What I'd like to do is, I guess, just pull this audio mixer out into its own separate file, and at that point, you know, we can start to think about, do we want to go ahead and SIMDize it? Do we want to start adding some of those other features, that sort of thing? So I'm going to call this handmade audio.cpp for now. I don't know if that's particularly good word for it or not, but I think that's what we're going to call it, so there you go. So I'll grab this guy up here, which is our test sound wave. Our sine wave, rather. I'm just going to call this like output test sine wave or something like that. And I'm going to pound include here handmade, handmade audio.cpp. And I will also up here include a handmade audio.h. There we go. So we've got two new files there. And I'll go ahead and grab anything I see here with the audio stuff. We've got a playing sound, right? That's going to go in here. I don't know that we've got really much else. We'll pull these guys. We'll pull these guys out potentially. We'll take a look at that in a second. All right, and let's grab that mixer. All right. So here's the mixer. Internal void. Let's see. Output mixed sounds. Something like that. I don't really know. Output playing sounds. So let's grab all that up. There we go. And see what this guy actually needs. It looks like he needs sort of that sound buffer, right? He's going to need the sound buffer. So that's like, what is it, game sound output buffer? So sound buffer. He's going to need, does he actually need trans state, or does he just need to know what arena he is supposed to use? It looks like he needs the asset array and the arena. So I think he just needs game assets, he just needs the asset array, and he needs you know, a memory arena, right? Like so. And this is just a temporary arena, right? So that's all he really needs is a temporary arena. I don't think he ever needs. Does he need anything else? No, I don't think so. So let's go ahead and say temp arena there, temp arena here and here. So he's just, you know, yeah, doing some very, very simple, straightforward stuff there. Okay. So he needs the first playing sound. And let's see. So that's assets here, the assets there. There we go. Still game state. There's the assets again. The first free playing sound, first free playing sound. Okay. So now I'm not really going to go overboard here. I'm just going to say that we have, you know, game audio or something like this. Game audio state. I don't know. But basically that game state structure, I'm just going to grab out these two here and put them inside this thing, right? and I'll just say audio state like that. And then when you call this function, output playing sounds, you'll have to do something like this. And then when it does game state, it'll just say, audio state or whatever. And that'll just be a way for us to keep this isolated a little bit and make sure we kind of know what's going on here. So audio state, I think that's all we really have to do. Yeah. This is just a, oh, well, you know what? And this play sound function probably should go in there too, huh? Maybe we'll do that in a second. So audio state and audio state. There we are. Audio state. Okay, so we've now pulled it out into its own file. Oh, well, and you know what? It's probably not going to play anything if we don't call the function. So let's go ahead and grab that and actually call it. So down here, what we want to do is call output playing sounds. We want to play that on the audio state like this. We want to pass it the sound buffer. We want to pass it the assets and the temporary arena, right? So that's really it, I think. Yeah, so I think that should just play, right? Yep. So that's all good. And I'm going to grab out, again, that's that play sound function. I'm going to try and grab that guy out as well, just because that seems like kind of a obvious something that would be in the audio state there. So really what we would need to do here, I'm going to put this in here for temporarily. But what we would want to do is we want to figure out what arena these guys are coming out of. And it probably wouldn't be the world arena, right? It's probably going to be something that has to do with the audio state. What we can do, however, is we could just for now, to make this actually code be relatively correct, without actually knowing any more about it, we could just say that it's got an arena that it gets its sounds from, right? This is its its sound tracking arena basically, and its permanent arena, I guess you might say. And so we could go ahead and say that it's going to get its memory from there, and then you pass audio state in here, right? And it just always uses whatever that arena is that you initialized it with. And so when it does its push struct, it's going to use audio state perm arena, which is going to be whatever arena you told it to use when you started it, right? And that way that'll let us not have, this code won't have to care anymore. When we go do a little bit of our memory reshuffling, when the time comes, we'll just pass whatever we want to pass to game audio state and make that work, right? Okay. So let's see here. So we've got our audio state stuff. So we just say audio state like so. And when we do play sound, game state, audio state. And that is all we should have to do. We do need one other thing, which is when we start things up, we would need to sort of initialize that. So somewhere in here when we actually do our initialization, I want to do something where we let's see, we initialize the world arena. I want to do something here where we go initialize audio state, and we just say game state audio state, and I'll pass that the game state world arena like so. And so then inside Handmade audio, we'd have a function here which is just going to do exactly that. It's going to say audio state. Oops. Hey, we're right at the end as well. I wonder if it should just be, is there a reason why I said game audio state? I'm just going to say audio state as well. Game audio state seems like a waste of typing. And memory arena. And so audio state perm arena is just going to be that, and then first playing sound will be the same as first free playing sound. All of those will be 0. And that's that. So I think that's it. I think that's everything that we need. And Yeah, good deal. Not bad for an hour's work. Excellent. All right, so let's go ahead and go to the Q&A. There we go. If you could, please prefix your questions with Q: so I can see them, and please keep them to things that we talked about on the stream. On topic, please. Also, while we're waiting for the first set of questions to come in, I'm going to help out folks who are on Linux. I think Martin's wrote in, and I asked, what do you guys want me to put in here for letting LLVM properly handle this. He was saying that that sync val compare and swap doesn't want you to do the long star. It wants to automatically determine what the correct thing is. Otherwise, it was gonna actually do a 64-bit swap there, or something like this. And so this was actually the better way to do it. We're not actually compiling on LLVM, but there's a lot of people out there who actually are. So I try to just tell them, post on the forums whatever you need me to replace the platform header stuff with for now, just so they can all stay compiling until we actually go do our actual ports to LLVM platforms. I kill Team 03. You should apply for a sub button. Actually, Twitch already allows us to have a sub button. The reason that we didn't do it was just because they had a restriction in the contract about not being able to post YouTube archives of our episodes for 24 hours, and I didn't want to delay that posting, so we just didn't want to do it. So Twitch actually offered that to us. They're very nice people. It was just a contractual thing, so that's the reason we don't have a sub button. Let's see here. What is your favorite genre of music, and do you see it influencing the atmosphere of the final game? So I guess that's a very interesting question, and I guess I'll say a little bit about it. It's not super on topic, I guess, but since we were doing music, what I would say is, in general, I take a lot of time to define how things work artistically in games together when I'm working on them. In the case of Handmade Hero, there's a lot less of that just because of the nature of the development process. Like, it's an hour a night, and it has to be very different in the way that it develops as a result of that. So Handmade Hero is not really a game about fanatical atmosphere curation, which might be something that I would ordinarily do. It's more about just sort of going with the flow, because I feel like it kind of has to be that way in order to still work in the way that it is being developed is so atypical, right, with this 1 hour night thing. And so no, it's not, my favorite genre of music is not really going to influence the atmosphere of the final game, but that isn't to say that couldn't be true of some other game that I worked on. It's just this particular game has to be more about letting things happen organically and less about controlling them, because just the way that it's being developed, there's really no way to do that. It's hard enough to do those kinds of things when you're working 8 hours a day on something and have the ability to make those kinds of specific moves. But with the way that this game goes, it just has to be very organic. So we'll play it fairly fast and loose with a lot of things. And that's why I also try to make the sort of theme of the game in general to be very lighthearted, because it really wouldn't be appropriate to try and tackle like a complex subject, given the way that the game has to kind of evolve. Would you sell your game to a major company for a lot of dollars? No, I mean, I don't know what that means, sorry. I think I missed the day you added the music. What is the track from? Will it be in the final game? No, that track will not be in the final game. I mean, unless we want to stick it in as an Easter egg. I have a long time ago, I did a piano practice blog where I would just like do ad lib practice. So I just sit down at the piano and play for like an hour or whatever. And then I would just take a chunk of that and upload it. And so this is just, I wanted a thing that I knew would be completely copyright free, right? Well, not copyright free. I needed something where I knew I owned the copyright entirely. And so that was something that I owned the copyright entirely to, so I put it in there so I knew that I could just release it and not have to worry about it. What is the reason you use a temporary arena in the mixer instead of a normal arena? The reason is because it is memory that only exists during that function, right? So what you can think of, right, is when you come into, and this is just a artifact of the history of C, and of course, you know, the C++ never really thought anything through or added usable features to C. So we're kind of stuck with, when you're writing in C, you're basically still writing, how should I say this? When you're writing C code, you're effectively writing in a language that was absolutely breathtakingly well done for the 1970s, right? So I have a tremendous amount of respect for C and what it achieved in the 1970s. Essentially, the C++ standards community has never actually made any meaningful improvements to it. So all of the things that you actually would want to do as a production programmer that have changed since the 1970s, you can't actually do, right? And so one of those is the fact that you don't have the ability to talk about memory in a useful transient way. And so they had a thing that was alloc-A, which was poorly supported and not really a thing, that allowed you to say, I need a certain amount of memory, but you couldn't actually do that very reliably. It would allocate it on the program stack and all these other sorts of things. So as a result, in C, it's very, very simple for you to have temporary local variables, right? Like if you think about where this stuff lives, like where does this pointer, real channel 0, real channel 1, dest 0, where do these live, right? Well, they live on a piece of temporary memory that C itself set up for you, right? Because the programmers who wrote C knew that it was important to have temporary scratch space where functions did their work, and you didn't want to have to manage it all the time yourself, right? Well, unfortunately, that logic actually extends much further than simple temporary variables. And actually, most lines through a path of code can be thought of as one or more overlapping temporary stacks of memory that get unwound at different rates. And I think if the people who had made C had been in their programming prime today, they would have known that and they would have had that ability in C, but they didn't. And so what we have to do when we program in C is we have to be able to represent that fact, that there are multiple overlapping stacks of temporary memory that are getting used by any individual routine. Some of them unwind when the routine ends, some of them unwind when the logical operation that this routine is a part of ends, and you've seen that as well when we did our task stuff. And managing those is very easy once you create something like these little arenas that I made, but unfortunately you have to do that work yourself because, again, like I said, C++ standards community doesn't understand things like this, so they don't put in proper support in the language for them. That's just the reality of having people who don't do serious production programming, you know, making your language decisions. Or maybe it's just designed by committee. I don't know. I don't know why C++ doesn't understand these things, but they don't. So as a result, we have to do them. But once we've done them, we can basically make our routines work work the same with arbitrary blocks of memory that need to get unwound at different rates, or that are very large and wouldn't necessarily fit on the temporary stack, or things like this, or where we don't know how big they would be ahead of time. Like, that's a big thing, right? We don't know how big this is going to be ahead of time because we need some temporary memory here that's based on a thing that's actually passed into us. So we don't know how big that's going to be. So all of those things we can actually do very well and do them in a very convenient sort of almost zero cost way, unlike something like, you know, garbage collection or things which have a lot more overhead and things to think about. We can do them very easily just by using these arenas. So the reason that we use this temporary memory here is because what we need to do is we need to make floating point mixdown buffers where we can mix all of our sounds into it, and then only at the very end actually convert those buffers into the final destination buffer, which is a 16-bit integer buffer. So what we do effectively here is we do exactly the same thing that the C language is doing for us with our temporary stack variables. So just like this temporary stack variable here, these are effectively temporary stack variables that just happen to be huge, right? They happen to be sample count times 4, right? That's the size of this thing, big. And we have 2 of them. So we're talking about, 8K or so, I don't know what we're talking about. We're talking about something like that, right? So we're basically just reserving 8K of space out of our memory pool. We're doing all of the work that we need to do, and then we're going to release immediately that in there. And because we don't want to spend any, we don't really want to spend any CPU time to do this, we can use these arenas are set up to do this very quickly. All they do is just increment a value. It's just like, a plus and then a minus, right? It's just a very simple add and remove. There's no thinking that goes on. It's always 100% deterministic and clean. And so that is really important. And again, you saw me do some of the more extended things about this back when we did the task system, where I said, let's make an arena that just works for this one task. And that creates essentially like a secondary overlapping stack, right, that can operate. So typically in a complex environment, you often have 3 overlapping stacks. You have 1 overlapping stack for your temporary stack variables and the program call stack. You have 1 temporary thing, which is basically like for large regions of memory that you need to work on temporarily, which is what we're using here. And then you have a final one, which is kind of like something that persists for the length of a logical operation, not a function, right? And that is what you saw in the task thing. And that's very, very common if you manage your own memory and get memory management out of the equation in terms of CPU costs. So you literally are spending almost no time doing any memory management, like you're not doing any locks, you're not doing any thinking, you're not doing any free, rearranging or any of this stuff. You're trying to get all of that out of there and just doing something efficient. You typically have like a 3 overlapping stack pattern like that. And so that is what you're seeing here, is you're seeing one of those overlapping stacks being used to get some mix bins that we can use to put stuff into. We got some new blood asking about the absence of Java. Could you please help clean the chat by doing another Java rant? I don't usually rant against Java because I'm not, really a Java. It's not like I programmed in a lot of C++ heavy stuff, and I feel qualified about ranting about that because I know it's very bad. Java is just not interesting. It's not that I'm going to rant against Java. Java is just not a very low-level language, right? Java runs through a virtual machine or a JIT, which means you really don't have any control over what the actual computer is doing. You have what you're doing is it's sort of a rubber pencil, right? You're trying to tell some other person's very large, sort of unwieldy piece of software what you want it to then tell the machine to do. So it's kind of like playing a game of telephone, right? Java is. C already has a few unfortunate parts of that where you can't really tell the compiler exactly what you want it to do, but you can it's pretty close, right? Java adds this really big stack in there, and also it's garbage collected, right? Which is no good at all. That's just a huge waste of time and resources, and so that's and I mean maybe you can turn that off to a certain extent. But again, once you start turning off all those features of Java, you basically end up getting back to C, and then it's like, well, why did you get all this encumbrance? It's an encumbrance that costs you something at ship time too, because now you also have to ship all of this Java bulk. You write something in C, you can ship it by itself. It's an executable, it just runs, right? In fact, I often make things that just run. They don't even have to have a redistributable. It's just an exe you can just run. It just works, right? And that's completely out of the question for Java, right? I mean, Java, you have to, at the very least, bind all of this stuff into your executable that's like a Java VM or a JIT compiler or all of these like additional dependencies that brings in for you. Not to mention the fact that if there's something wrong in those dependencies, there's nothing you can do to fix it. You just have to wait for the Java world to come and do it, right? So, I really don't like things like that. I don't want any additional stuff between me and the CPU, right? I want just things that allow me to make it easier for me to tell the CPU what to do. I don't want people making decisions for me about what the CPU should do. That just doesn't help me, right? That just gets in my way. And so any of the things that Java might do for me, I can just write them myself once, and there's typically not that many things really that I would ever want from Java that I've ever seen. But if there are, you can just write them yourselves once, and then you're off and running and you're done, right? You don't have to worry about it. So there's really just not a lot of benefit to Java. I don't see the bonus of it. And I would also just add the fact that if you're talking about game programming, well, game programming just isn't done in Java. Just period, right? Pretty much all games are written in C or C++. There are very, very few notable exceptions. Minecraft is probably one of the only ones that comes to mind of an actual game that anyone's actually heard of that was written in Java. Pretty much every other game that you've ever heard of is written in C. And that's not an accident. Well, C++, I should say. That's not an accident. There's a real reason that people don't use Java for games, because it's just not suited, right? It's not the appropriate platform for writing games. Let's see here. Man, there is a lot of questions today, but not a lot of those questions are actually on topic. I'm just trying to scan through and see if there are any questions that are actually on topic before I just add some more off topic if I answer some more. Fad Gasket says, are you now streaming long audio assets from disk? Tuned in late, apologies. I realize this probably already has been discussed. Yes, we are now streaming long audio assets from disk. That's what we did today. Let's see here. Yeah. I can't remember the technical explanation, sadly, but one thing I think we need is a fade out when audio stops rather than a dead stop to avoid a loud click. Well, yes and no. So the only time that you need the fade out when audio stops is if the sound assets themselves do not properly attenuate at their edges, which they normally do, right? And so, typically you don't actually need it for that. So I guess the way I would say it is, typically you don't want to fade out your audio when it gets to its end. The audio should be authored to properly go down. So the thing that you're possibly talking about, I don't know. If that's what you're talking about, I just want to mention that first. But the part where you actually do need the thing that you're talking about is when you want to stop a sound prematurely, right? And that's definitely true. And that is what one of the things that we would like to have volume attenuation for. We would also like volume attenuation so that when a sound wants to start, in the middle of it potentially, or things like that, we want to be able to ramp it in. And even if those weren't true, even if we weren't trying to avoid the click, it's just jarring to the user, right? We don't necessarily want a sound to stop immediately. Like if there's full volume music playing, it sounds very odd for it to stop, even if it wasn't a problem of the clicking, right? What we want to do is be able to attenuate it over time. And so that's one of the reasons that volume ramping is important and one of the things that we want to do. And I talked about us wanting to do that last week, so we will definitely do that this week, possibly tomorrow, possibly a little later on, depends. But and also, like I was saying, volume attenuation over time is also what gives you stereo panning if you want it. So we need it for like a number of reasons. Once upon a time, the number of hardware channels available on a sound card was important. Do most games these days not care because doing these things in software is fast enough? Yes, that is exactly the case. Sound is now very small compared to the power of the CPU, and so most of the time, mixing is not really relevant in terms of your performance profile. I mean, you can kind of see this already, right? So what you saw on the stream was just trying to fill the whole 1920 by 1080 screen. When we didn't optimize our code, just doing that was too slow, right? Because there's just a lot of pixels on a 1920 by 1080 screen. Now, we were able to optimize it, and now we run really well at 1920 by 1080. That's true. So certainly, we were able to make that work and all. But we had to do some actual work to get a performant graphics system written by hand, right? So you can kind of understand why using a GPU, like when you're talking about using a GPU, we wrote everything in software, so we render everything ourselves with the CPU, right? But when you think about a GPU, you care about how powerful a GPU is because it's still on that cusp of not being powerful enough for all of the things that you might want it to do, right? It's still graphics. There's still so much. Why did I accidentally? Okay, there we go. There's still so much horsepower required to do graphics because there's just a lot more pixels than there are sound samples that get output for any given frame. You're just in this situation where you actually really do care how powerful your GPU is because it makes a meaningful difference. Sound just is not that way. Sound, there are only 800 samples or something. I mean, just you do the math and you think it through, right? It's like, okay, for a sound buffer, I've got 800 samples. Maybe I've got 7 channels, and those things are like too long. So we're talking about 11,000 bytes back of the envelope that we're working on. 11,000 bytes. I mean, think about that. 11K or 10K. It's so tiny, right? Compare that to 1920 by 1080 for an HD TV, right? Something like this, and consider that you have to do at least four bytes for color on there, and you're doing 30 of those whole ones a second. I mean, look at that number, right? So the previous one we were talking about something. I guess I should also multiply the other one. Let me multiply the other one out to 30 for a second. There we go. So yeah, I don't remember what I said. Maybe 800 times 30 times 2. Right. So there you go. So you look at the magnitude of the numbers involved here, and I apologize, like my calculator skills aren't great. I may not have quite done that exactly, but I believe this should be roughly correct. If you look at the magnitude of how much processing has to happen, like how many individual things you are trying to calculate, there really just is no comparison between sound and graphics. And so as a result, CPUs nowadays are so overpowered for doing sound stuff that it really just is not relevant. You don't need a separate processor to take any of the load off because it's just minuscule compared to what a graphics workload looks like, and CPUs are now capable of doing graphics workloads, at those scales even, as we've proved on Handmade Hero. So yeah, so sound cards are just not useful, and that's why they try to differentiate themselves with other things like how many speakers, weird configuration, processing stuff, I don't even know. They try to add extra things to make themselves valuable because they need to, because there's really no need for them. What is not true is that compression is not always, or decompression I should say, is not always free. If you want all of your sound files to be compressed with fairly heavyweight compression, such as MP3, Ogg Vorbis, these sorts of things, that decompression can start to get expensive. And so if you're in a really rich soundscape, you're talking about 256 sounds or something like this, all happening at once, and those are all getting decompressed in real time because you want to save memory footprint on like a console or who knows what's happening. You can start to get into cases where you do care about the CPU load on decompression, but that's exactly the kind of thing that sound cards don't actually do, right? So if you actually had sound cards that were about doing like Ogg Vorbis decompression or something, then you might start to care again how many channels they could do, because that might be actually valuable, I don't know. But that's sort of more what it's about. If you're just talking about mixing, doing it in software is really just too simple. There's no need to make that a coprocessor job. Let's see. Would you ever need any kind of MP3 Ogg support in Handmade Hero, or is Wave okay for music here? So I think that answer is going to come down to do we care about the game's disk footprint, right? Because I think we wouldn't really care about good music compression unless we cared about disk footprint. And disk footprint can be relevant in two different ways, right? Disk footprint can be relevant if you just plain care about the disk footprint, right? Meaning if you're just trying to make your download size smaller or patch size smaller, just like if you just actually care about how much room the thing takes up on servers across the wire and on the user's machine. If you care about that, music compression is a big deal, right? Because it's going to give you 8:1 or something probably, or possibly more if you do MP3 or aux-port, depending on how much quality you want, whatever, right? And 8:1 is a pretty big deal, especially if you have a lot of music in the game. That's a big deal, right? And the other place you care about it is transfer time. Like we're doing all of our asset streaming already, right? All of our bitmaps, all of our sounds are all streaming in. And we haven't really tried to work on this end of it yet, but when we get towards ship time, we're going to be in a situation where we want to make sure that our asset streaming always stays ahead of what we actually need so that you don't have dropouts, whereas you don't have things blinking away. Like right now, right, we're just in development, so it comes up and you see the stuff stream in, and that's fine because that's just all we're doing, right? We don't care about that. But in the final shipping product, we won't want that to happen. That's unprofessional. We don't want that, right? So what we want to do is make sure the streaming system's always ahead, and if the streaming system can load less data, like if it can get the MP3 decompression time down to less than the amount of time it would take to read it off the drive in a slow drive scenario, potentially, right? Which is entirely plausible these days, given the fact that a lot of people still have, they're playing on a laptop with a 5200 RPM drive, like the slowest drive you could imagine, right? But they've got an Intel Core i7 in there or something like this, right? It's entirely possible that you might be able to Vorbis decompress some stuff in less time than it would take to load the equivalent chunk off of disk. And so that, again, also saves you some time. So I don't know if either of those two things, if we will care about them, but those are the reasons that we would have to start looking into music compression of some kind, right? I would like to avoid it if possible because it's kind of a rat hole that doesn't really have a whole lot of interesting stuff in it. From my perspective, because I'm not really a music compression guy, so the amount of insight I'm going to be able to give to people on the stream about what it means to have something Vorbis compress and whatever is just not going to be that great. So there's that. But if we did end up in a situation where we need it, what I might do is ask somebody like Jeff or Fabian or Charles to maybe just do a guest stream where they explained how to think about music compression or something like that, so that it wouldn't just be a waste of everyone's time, like, okay, here we're slogging through an Vorbis decompressor, blah, 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 right? Let's see. What do you wish you could change? That's not really on topic. Let's see. Would a garbage collector help us with managing the sound buffer and chunks? I'm not sure what you mean by that, but assuming that you mean in the asset system, the answer is no, because so I think people seem to get this confused a lot. We've actually had questions about this before. So you have to understand the difference between virtual memory and garbage collection. They're not really even related, if that makes sense. They're completely different things that solve completely different problems. So a garbage collector is when you want to keep memory around, data around, until nobody knows about it anymore, right? So basically a garbage collector is about who in the program can see this data and might use this data, and then as soon as nobody uses the data anymore, we want to get rid of it. That's a garbage collector, right? That's why it's called a garbage collector, because it's once something becomes literally garbage, like you don't need this data anymore. It's garbage. The collector comes and collects it, right? Virtual memory is about having more data than you can fit in your working space, but you want it all. And so virtual memory is about saying, what of it do I want right now? Let's make sure that is resident, right? And so what we implemented in the asset system was virtual memory, basically, a form of virtual memory. There is no garbage in our asset system. It's not garbage. every single sound is valid data that we want to play in the game. Every single bitmap is valid data we want to display in the game and will display again and know about the entire time. What we don't have the ability to do is necessarily load them all in at the same time for two reasons. One, it'd be too slow. It'd be this giant loading screen, right? And two, it would cause us to require a very large memory footprint, right? Or give up, like maybe our worlds would have to be smaller to fit all those assets in, right? And so what we want to do with the asset system is just say, let's create sort of a dynamic view into this where we're only going to have the stuff in memory that we're actually using at any given time. And when something new has to come in, we're going to evict something old based on whether or not we think it will be used again in the near term, right? But it is not garbage. We are not throwing it away. And a garbage collector would not be able to help us at all here, because a garbage collector is not about that knowledge. A garbage collector is about knowing that something will never be used again and throwing it away. But in our case, we always know about everything. Everything is possibly to use. So the algorithm does not look like a garbage collector in any real way. All right, I think that's about it. So I think we will call it, because we are out of time, and most of the questions did not look to be on topic. So I guess what I'd say is, for people who have off-topic questions that you'd like to ask, we do off-topic questions at the beginning of the stream. So if you come back tomorrow at like 4:45, let's say, the stream starts at 5 typically, come back tomorrow at 4:45. That would be the time to ask the off-topic questions, and then I can answer whatever questions you have. But I try to keep the on-stream questions to ones that actually are related to the stuff that we're working on, so that we can not get too wildly off-topic, as things sometimes want to be. All right, so let's go ahead and close things down here. There we go. Okay. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you want to follow along at home and play around with the source code, you can always do so by pre-ordering the game on handmadehero.org. And it comes with all the source code, so you'll get a little download link that you can use every night to download the source code. After I'm done with it, then you can play with it. We also, if you just want to support the video series, we have a Patreon page you can subscribe to. It's also very much appreciated if you would like to do that. And we also have a forum site where you can go to ask questions and to get ports to Mac and Linux that community members have done if you're trying to follow along on a platform that's not Windows. Until we get up to those platforms, that's a good place to go. We also have a tweet bot that will tweet the schedule at you, and so if you want to catch the stream live, that's the place to do it. I think that's basically it. Have I said everything that we need to say? I don't think there are any additional items. So that's about it for today. I will be back here tomorrow at 5 p.m. So please join me then if you would like to see some more audio mixing coding. We'll probably do volume ramping and maybe look at like panning and that sort of stuff. We'll probably start doing that tomorrow, and I don't know how long that'll take, maybe a day, maybe two, and then from there we'll probably go into the SSE stuff, SIMDI's the mixer, and then that's it for the mixer. We can probably just put it away. There are some interface things we might want to play with in terms of how you can control sounds that are playing, but we'll look at that probably when we're doing the volume ramping. So that's about it. Thank you very much for joining me. I hope to see you here tomorrow. Until then, have fun coding, and I'll see you guys on the internet. Thanks, everyone.